The many sides of the supernova remnant Cassiopeia A, located 10,000 light-years away in the plus northern constellation Cassiopeia. Cassiopeia A is the remnant of a once massive star that in a violent supernova explosion 325 years ago. Hubble Space Telescope, Spitzer Space Telescope, Universal Images Group via a beautiful supernova remnant in the night sky consisting of the leftovers of a star that violently exploded in the 17th century may have collided with something according to a new paper accepted for publication this week in the Astrophysical Journal and now available online. The paper looks at 19 years of observations of Cassiopeia A, an expanding cloud of gas and dust that has been getting a lot of attention in recent months. Cassiopeia A is about 10,000 light-years away in the northern constellation Cassiopeia and measures around 16 light-years across. It's remnant of an exploded star in the Cassiopeia constellation that would have technically first been visible from Earth in about 1670, though it was initially covered in too much gas and dust. It's expanding at up to 3,700 miles 6,000 kilometers per second and has a temperature of about 54 million degrees Fahrenheit, at 30 million degrees Celsius. It will soon be stood by the newly launched James Webb Space Telescope. The constellation of Cassiopeia. The Cassiopeia A supernova remnant can be seen through a telescope. Plus, just to the upper right of the star Cath in the upper right of this illustration. The researchers used data from the Chandra X-ray Observatory, an X-ray satellite that orbits the Earth. What they found was on the western side of Cassiopeia A, its inner regions are moving inwards while the outer shock wave is accelerating. The backward movement in the west can mean two things, says Jacco Vink, Anton Pannekoek Institute for Astronomy, Gravitation Astroparticle Physics Amsterdam, at the University of Amsterdam, in the Netherlands. Either there is a hole somewhere, a kind of vacuum, in the supernova material, causing the hot shell to suddenly move inwards locally, or the nebula has collided with something. The researchers' date suggests that a collision is most likely, probably with a massive shell of gas particles. An image of Cassiopeia A showing only two shells of nebulae. The blue arrows on the right plus show that the inner shell is not expanding outwards at this point, but inwards. The red arrows show that the other remnants do expand outwards. J.Vink at astronomy.nl. On February 14, 2022, NASA published the first image from its new Imaging X-ray Polarimetry Explorer, which launched in December 2021. IXPE is up there to study some of the most mysterious and extreme objects in the universe, so it was fitting that its first image, pictured below, was of Cassiopeia A. This image of the supernova remnant Cassiopeia A combines some of the first X-ray data collected by plus NASA's Imaging X-ray Polarimetry Explorer, shown in magenta, with high-energy X-ray data from NASA's Chandra X-ray Observatory, in blue. NASA CXC SR-X. The image shows that the shock waves from the ancient explosion have swept up surrounding gas, heated it to high temperatures, and accelerated its cosmic ray particles to create a cloud that glows in X-ray light. That's X-ray light is the magenta color in the image. Researchers are currently working with the data to create the first-ever X-ray polarization map of the object. This will reveal new clues about how X-rays are produced at Cassiopeia A and how and why it works as a cosmic accelerator. Wishing you clear skies and wide eyes.